Okay, chapter 10, chemical bonding. Back in 1989, researchers discovered the structure of HIV protease. This is an enzyme in the HIV virus that is necessary for it to replicate. And by understanding the structure of that enzyme, researchers were able to apply bonding theories to simulate how potential drug molecules would interact with that. The idea was if we can shut this enzyme down, then we can stop AIDS in an individual. So this is a representation of the HIV protease, and in order to shut it down, you need something that's going to bind to its active site and prevent it from doing its job. So indinavir was found to be a good protease inhibitor. This research was much faster and more efficient because instead of just trying random things, they were able to look at the site and see, well, what shape does the molecule need to be? Let's try some molecules that are that shape, and they were able to find it much faster. So bonding theories can really aid us in discovering answers. A bonding theory predicts how atoms will bind together to form molecules. It'll help us to understand what combinations actually form compounds, what combinations do not form compounds. You can't just take a couple of atoms from the periodic table and write a formula for them and have them be an actual compound. It doesn't work that way. Only certain combinations work. So we can predict the formulas of the compounds, and we can also explain the shapes. And the shapes determine a lot of other chemical and physical properties. So there's different theories. Lewis theory is the simplest. It doesn't work for everything, but it's very useful for quick, everyday predictions about molecules.